This is Chapter 6, Frames and Machines. We are looking at equipment that has pin-connected multi-force members subjected to 2 or 4 more forces. That is, the members are the frames. They support loads. Machines, they contain moving parts and designed to transmit and alter effects of forces. Both frames and machines are designed to have no more members that are needed to prevent its collapse. Forces at joints and supports can be calculated using equilibrium equations. So we're always going back to our equilibrium equations. And once these forces are found, we'll be able to design what types of materials we need, but not in ET 240. That'll be in your materials class once you get there. So when we're looking at a frame or a machine and we're going to analyze it by looking at the forces within the members, this is going to be our analysis, our process. We want to disassemble the frame or the machine. You want to isolate by isolating each member. You want to show all the forces on that member or on each member. You want to show distances and any couples that are on that member as well. Show a reference axis. And you want to identify 2 force members. And we'll get into that in some of our examples. It's also, you can go back and look at chapters, I think it's 5.4, take a look at those. That'll help you as well. This identifying 2 force members helps eliminate unnecessary number of equilibrium equations that you may need when you are looking at that member. Forces shown on any 2 contacting forces, these are shown in opposite direction and equal magnitude. So for instance, if I was looking at A, B, C, D, so you have that member there, A, B, C, D, which is all one piece of metal or whatever material that is, and then you had C and E. If I was to look at the forces, let's say I wanted to say this is CY and this was CX, I would go opposite and equal on the other member that I was looking at. So I think the best way to look at frames and machines, again, is to look at example problems. And if you notice, all of this are free body diagrams. So you break these up and you're pretty much doing free body diagrams on each member. So let's just go ahead and look at this frame here. I've got a member AB here, and then I've got CB here. And you notice this is one piece. So this is going to be a 2 force member here. So I've already kind of drawn out, and I have AB here, point B here, and this is B as well, and then this is point C. So let's look at this object here, and let's go ahead and draw the force on it. So if I had that force there, I'm going to have 400 newtons as well going down. Now if we looked here, opposite and equal, now I'm going to have a force acting right here, and I'm going to have a force acting opposite and equal, so that's going to be 400 newtons, and this would be 400 newtons just by looking at equilibrium equations. So if we called this point D, that point there would also be D. So we could come in and say, alright, so if I had this going up at 400 newtons, this one going to the left, at that point, at that joint, I am going to have 400 newtons going out, and I'm going to have 400 newtons going down into that joint, opposite and equal. At point B, what do I have? Well, if I look at CB, this is a two-force member. So I could come in and write my forces on this. And these are directly going into each other there. So what I have here is I've got 3, 4, 5, and also here it would be 3, 4, 5. This is going to be force of BC, force of BC. You could then look at breaking these up into its component forces by saying BY and BX. And the same thing down here, CX and CY. So looking at this, we know that CY is equal to BY and CX is equal to BX. Now, transforming this back up into our member ABD here, I have opposite and equal. So on point B, I have this force going down into it. I would have my force FBC going into point B at a 3, 4, 5. And notice how now I have opposite and equal going into B. Again, it would be opposite and equal, so it would be BX would be going to the right and BY would be going up. And then we would have our forces on AY, which would be, I'll just put them going in this direction here. And I would also label my distances. As so. This is just a quick free body diagram of our frame and each component on that frame. Now note, I have drawn a bunch of forces on these, and these are all assumptions. I'm assuming that they are going that direction. If I compute them and they come out negative, that means they are going in the opposite direction. Now this piece, just by looking at the forces on it, I have opposite and equal actions on the joint. So I know that these are true, opposite and equal, so I know that D, this is what's happening at point D. So I hope this helps. I'll be posting 2 examples for frames and machines, probably 3. I'll probably do one more free body diagram example, and then I will be doing 2 primary examples, hopefully to help you understand the content of the subject. Thanks.